I've always heard breakfast, but he said science has proved
What science has proved that wrong?
I personally
I don't
think
know, I just said that today.
All right, so
St. Lawrence
first
was like,
thing
that's
we
the
need
one
to
thing they
do
fought was breakfast. They give us free breakfast.
is go back to the sheet that you were working on at the end yesterday, remember? And I thought what was on the board was wrong, and then I started looking at it and I had made a mistake. So I can't remember what was on the board yesterday. Does anybody know for number 6?
It was X17. Cole, you got it. It's your problem.
This
Where
was
was
number 6 on the back side, the
It's
very
that review
last
sheet.
column.
Review sheet.
Who did it on the board?
Cole. I'll let him say it.
And Cole got,
Pulling it up.
Wrong answer.
I don't remember. It was X.
Well, my answer was or the problem?
Let him answer.
X to the 15 over 4, and then Y to the 17 over 2.
oh, so close. I got 17 over 4.
What? What did I do wrong? What did I do wrong? Oh, I know. Yeah. I had. Wait.
No, it used to be.
Yeah. It's supposed to be 4. Sorry.
Okay. So, that was the right answer almost yesterday. So let's walk through that real quickly to make sure everybody's on board with it. So we had, let's see, y to the 1/3, y to the -2nd, and x to the 5/3, y to the 3rd, -3/2, and the whole shebang's to the 3rd. Okay, now, there's a lot that needs to be done here, but the order that you simplify these things doesn't matter. Okay, so, I don't know, what do you want to do first?
Get rid of the -3 over 2.
This guy right here? Okay, so we have y to the 1/3, y to the -2nd. You mean just by distributing it?
Yeah.
Okay, so then we have x to the -5/2. I'm multiplying my exponent, and y to the -9/2. Okay, so that takes care of that little thing, and then the whole thing is still in 3/2. All right, what do you want to do next? Anybody, doesn't matter.
Get rid of the negatives.
Okay, so we can rearrange things inside the parentheses. So we're gonna have y to the 1/3 up there, y squared down here, x to the 5/2 up here, and y to the 9/2 up there, to the 3/2. Alright, so this came down, those came up. Alright, that's fine. Remember, the order you do this stuff doesn't matter, so this is great, this is fine.
And then simplify the y's.
So take care of, got a bunch of y's in there. So x to the 5/2, nothing really happening there. But we have, basically, we're gonna be adding a 1/3 and 9/2 and subtracting 2. Would everybody agree with that? If we're combining these guys? So our common denominator will be 6. So that's 2 plus 27 minus 12. What is that? 29, 17, 6. I don't have anything left in the bottom. Still 2 3. Everybody still with me? So now we'll just take care of that 3/2. And that's how he got x to the 15/4 and y to the, this is gonna cancel, 17/4. Perfect, good job, Cole. You okay with that? All right, was there anything else from yesterday we needed to wrap up, or was that really it? I can't remember actually. We're good on that? Okay. So I'm gonna give you a few minutes. We're not gonna, you don't have time to do this whole thing probably. So what you're gonna get is a set of equations, exponential equations, and then you're gonna get a set of their graphs, and you're gonna match them. Okay, so you're gonna match the equation to the graph. The graphs are on both sides. So Fred's gonna hand out the equations, I'm handing out the graphs. And you and your partner are gonna spend a few minutes trying to figure out what's what.
I have the post-it note in my bio folder.
Okay, does everybody have both things? You don't get the graphs yet?
Work hard on that.
No, yeah, no, his is a double-sided paper, and
We know that the at sign is.
the bad copy.
What those things? Get my phone.
Everybody know what you're doing?
Let's say K.
Yeah, how would we write that? Do we just put K? Like, you put K on?
Yeah, why don't you just put whatever, yeah, graph.
Okay.
So to help you keep track of your answers, go ahead and just put the letter of the graph wherever the equation is. So like if this is A, just put A.
Oh.
Wait, how do you figure these out? I'm just plugging, like, in my head, I know that to the 0 powers is 1, that's 1, and then that's the first, it's gonna be 1/2, that's 1/1, that's 1/2. Yeah, same thing, that's what I'm doing.
Oh, put part.
Carrot symbol.
Like if you plug in one, it's just like, so like plug in one.
Oh, we're done.
There you go.
It'll be plus 0.
Maybe this.
Actually, right, we have to get out of the bridges.
No, I don't definitely see. Okay. I mean, yeah, it looks the same.
The little star.
It's also a little bit higher. Wait, why are they all the same?
Hello, Dexter Morgan. Occupation. Isn't it like 7? Or yeah, 8. Come on, I think I'm almost done with 7 right now. This is so good.
On the season 1, episode 11. The,
Season 1s are so good.
season 1, and the ice truck killing.
Yo,
Yeah, but it's
season 4, oh my god, it's so good. Season 4
Oh, yeah,
and 5.
minus 1.
It's like you got 9 season 11. should.
I didn't really
You should watch it, bro. It's good.
The Winter Interceptor.
You know what else you should watch? Oh, shit. You know what else you should watch? Wolf of Wall Street at my house.
Ellie said?
Because that was also.
No, because the first time I heard about it.
That might be. I think I might have something else that day. You're gonna play Let's go. What you play, man?
No, that's cool.
You're on it.
besides this one. Wait, this one.
Which is actually gonna be so good.
But it's like
Is it a negative one or positive one?
She put on me. Is it not with the, let me do the project with you guys? I was in the nurse.
It does?
Yeah, because of the negative. Like there's
No, I wasn't. I was not feeling well.
But it's just a negative.
I also wanted to skip the quiz, but that's not relevant. You actually $50 at the nurse? You didn't think it'd be cool to mention that I like hopped down to the nurse?
I think it works.
How is that work?
I have to get the nurse.
I don't feel it. I'm not down there because I want to win the prize.
She she's like, she literally mentioned, she's like, so if someone's doing that, just trying to avoid this task, so I probably get up here. I was like,
Okay, no, she thought I was skipping because you didn't mention I was at the nurse.
dude, if my sister was
No, she saw the attendance, so she knew I was here.
she was with the nurse.
No, she didn't.
Does it not say?
Well, I don't know if the nurse like emailed or not.
It's only that you forgot. I didn't want to be like, yeah, he's my last time.
Well, one half
We
is
were
the
actually
rate.
talking about it. He was telling me how we discussed
Alright, what I would have done in said situation if you had to go. Yeah, I mean, I saw the math, but he seemed really sick. One nurse night, one night, nurse Saturday. Is that not what?
I get it. I just didn't want to like, right?
I did a couple of long reads.
Are you actually?
There can be multiple, right? You and my dad were talking about going like culinary school in Paris.
Your dad?
No, but he's like really keen.
Can I go with you?
Not like that, it's more of like it's something he likes to do too, so like he thinks that's really good. He said he funded like after I made all the
It's like a definite amount.
It has to be Vegas. So why intercept's gonna be 2?
I don't know if culinary school requires like good grades in school.
Really put 3 in
What?
each. This one 2. One interception leads 2. That one leads 1. Negative 3.
That's like 80,000. Literally almost just dropped a fence on me. So I'm gonna be like a Michelin star. Like you know Bear, the show.
No.
The chef.
Oh, I know what you're talking about. No, I do.
It's kind of like Gallagher.
Yeah, it's the guy who plays Shameless. I haven't seen it.
Yes.
Gene might be.
Bro, Pat, can you watch?
Gene might be.
Finish now right there.
If
No,
Stay
I
with
can't,
it.
dude.
Stay with it.
I can't.
I'm
I
with
watched
that.
the first episode and I was like,
That's what I'm saying. I'm
For
with
what?
it. I tried.
hey,
What you know about hoops?
Now I'm trying to get me into it. Hoops is fire.
All I'm saying is
Naruto's fire.
everyone that I know who has stuck with Naruto, Naruto is like the best anime of all time.
You guys roll on yours.
Let's
Alright,
focus on
alright,
that.
alright.
Avatar The Last Airbender.
No.
Alright, that's a cartoon.
A is the dog.
And there's stuff. And there's stuff.
Okay, I heard these guys up here say A is the dollar sign. You agree with that? Now, remember, you can look at picture A, and obviously if you put in 0, you get 1. But then if you put in 1, you're supposed to get 2. And if you put in 2, you're supposed to get 4. So I think the dollar sign is A. But did anybody notice anything? Look down at the or the, is approximately, the 2 squigglies. What is 8 to the 1/3 x, you guys? 8 to the 1/3 x means 2 to the x. So isn't that the same equation? So A is actually both of those. Graph A is both of those things. Remember, if exponents are multiplied, it means you've taken a power to another power. So 8 to the 1/3 is 2, cube root of 8. Okay, so that's A. A is the dollar sign and the is approximately sign. Okay, how about B? Anybody figure out where B goes? B is the percent symbol. Anybody have a question about that? I think that's the only one that's a B. Okay, what about C? Were you able to find any C's?
I thought B was percent and sigma.
B is percent and sigma. Let me find my sigma.
I have zero doubt in my capabilities.
The sigma is, alright, so 16 to the negative 2x would be 16 to the negative second to the x. What's 16 to the negative second?
4.
Yeah, it's 1 over 16 squared,
Oh.
right?
Oh, I thought it was a square.
No. How do you do roots? Roots have to be fractions, right? Fractional exponents are roots. Negative exponents are 1 over. So this is definitely a decay, but that is not the same as 1/4 to the x. Declan, do you see that?
Yeah, I did the negative first, so I made it 1 over 16 to the 2x.
Okay, that doesn't change anything. 1 over 16 to the 2x means 1 over 16 squared, which is still gonna be 1 over 256 to the x. If this were a half, Declan, that would be a different ballgame. If that were a half, then you would be rooting, and to get your 4, but as it is, you're squaring it. So, no, I think the percent is the only one for B. Okay, what about C? Did you find a C? Or did we already talk about that? I can't remember. Which one was C? The asterisk? The very first one, that was C? Remember, kids, you can check points. So when I look at C, if I put in 1, I get, or excuse me, if I put in 0, I get 1. But if I put in -1, I'm supposed to get 2. And if I put in -2, I'm supposed to get 4. It all works out, so I think you're right. The asterisk is C. How about D? Is there a D anywhere? The A thing? Swirly A? Good. How about E? Did you find an E anywhere? The hashtag? Is that the only E? Yep, I think so, good. How about F? Did you find an F? Exclamation point? So any question about the first 6 graphs, we good? Alright. Then what about G? What did you figure out for G?
The copyright and
Oh, there's 2 of them?
For which one?
Copyright.
Okay, yes. Yes, the pi and the copyright are the same equation, aren't they? Why did I make that J? Yeah, the copyright and the pi are the same equation. 2 to the x times 2 to the negative first, yep. So G is pi and copyright. Okay, what about H?
Ampersand.
The and thing? What do you call that?
Ampersand.
Okay, that's it, yep, that squiggly thing right in the middle there, that's it. All right, what about I? The carrot, carrot, that's I. And those, the ones with the -1 and the +3 and all that, those are easy, because you just look for where the asymptote is, right? So if you have a -1, you know your asymptote's at -1. Okay, so that was I. How about J? J is which one? The infinity symbol. How about K?
is that
The integral symbol? Yeah, that squiggly S thing, that's your integral symbol. And L,
Omega.
is that what that is? I don't know my Greek alphabet very well. Omega? The upside down horseshoe
that's
looking
exactly
thing?
what I was thinking.
What did you get? I did not get a match for the sigma. Did you?
No.
I don't think there's a match for the sigma. I think that's just an extra one there.
Can you go over the pi? That was like the same as the copyright.
Yes, because, remember, we did this yesterday, Gus. 2 to the x and 2 to the negative first would be 2 to the x minus 1. You add those exponents. And what's 2 to the negative first? 1/2. So it's the same as 1/2 2 to the x, which is the same as the equation pi. All right, well, that was fun. Okay, so put that away. Get your notes out, and we're gonna march ahead into 2.5. You'll need your calculators also. So get out your calculators. And these first few problems are gonna require us to do some thinking and some figuring. Last time we had to do that, there was a lot of frustration. We gotta get over that. We just have to be open to doing some figuring out. So, somebody wants to know what kind of function I have here. So I see these are all nice, so I'm gonna look at my differences, right? So what's my first difference here? That would be 6, and this one is 12, and this one is 24. Things are looking really good here. What kind of a function do I have? Exponential? Because what is happening to the first differences? They are proportional, aren't they? Aren't they all being multiplied by 2? Yeah, 2. All right, so that's, good, we've done that before. We're all set there. Now you're gonna write the equation for this, okay? Now, some of you, and we kind of cautioned against this, some of you are used to just looking at your y values. Well, these are not proportional. These are, you're not multiplying 7 by something to get this, okay? Something's happened. This is an exponential, and it's going to involve a 2 to the x, because these are increasing by multiple, or by a factor of 2. But we've done something. Take a look at these outputs. We've modified our exponent. Something has happened to the exponent. So take a look at these outputs right here. Or maybe not the exponent. Something's happened to the vertical shift. Look at these exponents. Look at these values here. Could you do anything to these numbers to make it proportional? Look at them carefully. You want them to be you want to be able to multiply by 2 to get from here to here to here to here. How would we have to change these numbers to make that happen? Subtract 1 from all of them. Let's subtract 1 from all of these numbers and then look at them. So 6, 12, oh my gosh, Craig's on to something, right? So if these are the original f of x's, then Fred says, let's look at f of x minus 1. And that's how he got these values right here. These are the f of x minus 1. He took these and subtracted 1. Now, these are still the x values. Could we write an equation for this? I think so. That would be 2 to the x. The initial value is 6. If you put in a 0, you get 6. But we have to subtract 1. Actually, no, we have to add 1. Because this, we're writing a new function. And our new function is the original 1 minus 1. So we have to add 1 to get our new function. So let's just test it out to see if it works. If I put in 0, do I get 7? Put in 0, do you get 7? If I put in 1, do I get 13? If I put in 2, I get 25, and so on. So this is the equation of that exponential function. All right, let's try the next one. First of all, we gotta figure out if it's exponential. So take a look at these y values. How are they changing? Well, this difference is 8. This one is 24. Oh goodness. What is that? 72. And that one is 216. Is that exponential? Let's start there. Is it exponential? Yes. Whatever our equation ends up being, it's going to involve a 3 to the x. Would everybody agree with that? Because that's what's happening to our differences. They're being times by 3. Okay, so now this is where you just have to think, all right? You just have to think. We know it's exponential. We know we should be able to write an equation like this. We have to figure out how to get those numbers. So, could we modify those numbers, make new y values, and make it so we were timesing by 3 to get from term to term?
+2.
+2? So change them into 4, 12, 36, plus 2. If we do that, then our initial value is 4, so it's gonna be 4 times 3 to the x. And then since the new function, if we have to add 2, that means we have to subtract 2 from, is that right? If I put in 0, I get 4 minus 2, yeah, that's right. And if I put in 1, I get 10, yep, so that's it right there. That is the equation of this exponential. All right, there's one more, try it on your own with your partner. Can you come up with, ultimately, with the equation? So first of all, figure out if it's exponential. That will give you your common ratio. That'll give you your base. Find your differences. What do those differences tell you about your equation? It's going to be 1/2 to the x. Would everybody agree with that? Okay. So then you got to think about what could you do to these numbers, add or subtract, to make it so as you move down through the list, you are actually timesing by 1/2 to get those numbers. Don't say it yet. Let's give everyone a chance to think about that. Did you come up with it? What did you come up with as your new y's, your adjusted y values? Did you think of something to do? Add 1? Will that work? I think that's a great plan, because now we're multiplying by 1/2 down the way. Our initial value is 64. And since we added 1, we're gonna go backwards, we'll subtract 1. Let's check it out, make sure we're right. Go back to the original points. If I put in a 0, do I get 63? And if I put in a 1, do I get 31? That looks good. How many of you came up with that? A few of you did? That's good, that's good. Yeah, just process it and think about it. All right, example 2. Number of fans inside the stadium. We're gonna write an exponential function. So your exponential functions, remember, are a times b to the x. After 2 minutes, there's 47 people. After 20 minutes, there's 2602 people. Use the given data to write 2 equations that can be used to find the values for A and B. So in other words, what we're gonna do is write our equation 2 different ways. So let's let our calculator do it first, all right? And then we're gonna do it by hand. So let's let our calculator do the regression. So we're gonna go to stat edit. And we only have 2 points to put in, so this will be easy. Get some stuff out of here first. Okay, so 2 and 20. And 47. Okay, we'll do an exponential regression. So On my calculator, I got 30.089 times 1 point, it'd be 250, I guess, to the x. Anybody else get that? Perfect. All right, so we can definitely do an exponential regression on our calculator. Now we're gonna do it by hand. That's what this writing two equations means. So one equation would be 47 equals a times b squared. And the other equation would be 2602 equals a times b to the 20th. Everybody see what I did? Alright, so now how do I solve that? I'm still gonna use my calculator without the regression, just for math. What would I do here to solve this system? This is a system of equations. What would you do, Alex?
Subtract the two, or look, well, once you do like, you would get b to the 18th, and then you would get, like what we have done on other problems.
I say divide by b squared and then make it equal to a and then substitute.
Okay, so what I was thinking about, Alex, see if this makes sense to you. A is 47 over b squared,
Yeah.
and A is also 2602 over b to the 20th. So I was thinking about setting those equal to each other, and then, well, then we get 47 b to the 20th equals 2602 b squared. Then we can divide out those b squareds, which is what you were talking about, I think.
Yeah.
And so b to the 18th ends up equaling 2602 over 47. Now that's kind of a, I don't know, a step-by-step way. You were talking about this right here.
Yeah.
That's fine. It's gonna give us the same thing. It's gonna give us b to the 18th equals that number divided by that number. Yep, that's perfect. So, I gotta find what b to the, or the 18th root. Of that number is.
It's the same numbers.
Oh, shoot. And I got that guy right there. Did you, hopefully? And then how would we get A?
Plug it back in.
Plug it back in, but we're gonna plug it back in without rounding it off, right? So, A equals 47 over B squared. So 47 divided by that answer squared should be 30.089, yep. So we needed a calculator for both of those. Here we actually used regression. Here we used just regular math.
When we're doing, when we're writing them by hand, should we leave our B as like, should we leave it like root 18 to the 2602 over 47, or should we put it like decimal?
That's a great question. It would be best to leave it that way, but I think usually, it absolutely was free response, I would leave it, but usually in a multiple choice question, there's a decimal in that rather. But yeah, that's it. The less you round off, the better it is. So, yeah, that's a great question. All right, let's go on to example 3. Here we go, same thing, we're doing this one by hand. You're certainly welcome to check it on your calculator if you wish. but it says write two equations and figure them out. So y, not y. Well, this is what I'm shooting for. So 21.54 equals AB cubed, and 3.62 equals AB to the 8th. Does that make sense to everybody for your two equations? All right, solve it. However works for you. Not with regression though, solve it this way, right here. Come up with anything yet? Y equals, what was your A? 62.801 times, I got 0.69999, a whole bunch of nines there, so I just made it 0.7 to the x. Anybody else get that? Nobody did? Oh, shoot.
Yeah, I got
I did.
You did?
I
Okay.
got 63, but I also do some penance. I don't know what we do once we cut that number. How do you find the fifth?
Okay, so are we okay with these two equations? So we're okay with that, right?
Yeah.
Okay, so I went ahead and 21.54 over b cubed equals 3.62 over b to the 8th. So 21.54 b to the 8th equals 3.62 b cubed. So b to the 5th is going to be 3.62 divided by 21.54, which, as Alex said when we were doing our geometric sequences, that's exactly what we would expect to happen. So then I fifth rooted that fraction, so 3.62 divided by 21.54. And then I fifth rooted it and got B to be 0.69999. Then, so that's sitting on my calculator. So then I know that A equals 21.54 over B cubed. So I just typed 21.54 divided by that answer, that 0.69 number, cubed. And I got 62.801. You find your mistake?
Yeah, when you put in, if you put in, like, if you just, yeah, I figured out my mistake, it was just a rounding error.
Are we okay with that? All right. So now we're getting ready to start talking about logarithms. So we gotta talk about E here. E is Euler's constant. It is approximately 2.718, but you have an E button, so you'll always use your E button. The number of bacteria can be modeled by this exponential function. Where T is measured in hours. All right, so question A says, write a new function of the form A times B to the T. So this is not A times B to the T. Any thoughts on how we could get A times B to the T? Alex?
You could, like you could do e to the 0.31.
Bingo. That's your B right there. There's your B. That's the thing that's being raised to the Tth power. So A is 17, and now B is e to the 0.31, just exactly like Alex said. So E is above your ln button. So it's 1.363. Now obviously this is much more accurate, but since they told me I had to have a B, I'm gonna have to round it off. And that's what I got. The number that's being raised to the Tth power is your B. And that number is this e to the 0.31, which decimally is that. Okay, now what? Find the average rate of change of B of T. So this is B of T. And we're going from 1 to 7. So B of 7 minus B of 1 divided by 7 minus 1. Is that okay for your average rate of change? So B of 7. I'm going to go ahead and subtract B of 1. And I'm going to go ahead and divide that by 6. What did you get? That's what I got. 20.952. Let's put a unit on that. What would that be in terms of a unit? Bacteria per hour. Find the value of T when the bacteria in this particular culture is 1,000. So in other words, we want B of T to be 1,000. Thoughts on that?
Graph the law.
We could definitely graph it. We graph, this is one equation and that is another equation. We could see where they crossed. We could also solve that using logarithms, they're gonna give you the same answer, it really doesn't matter, so do whatever flips your switch. Again, you would be graphing this guy right here as one equation, this as the other equation, and looking where they cross, or you're gonna set them equal to each other and use logarithms. We're gonna spend more time with logarithms, so if you're not sure how to do that right now, it's okay. I did it because it's faster to move and graphing. And we're running out of time. I got 13.144 hours. Did anybody graph it and get that answer? Okay, that should not be.
That's twice now.
Alright, let's graph it real quick and see what happens.
Let's do this.
Anybody else graph it and get this answer?
I did.
And got the same answer?
I got the same as you.
Graphing getting the
I
same
got
as you?
one. I got 13.
Mrs. Ford, I got the homework done.
Let me see what you got over there.
MSC.
I think it was mine.
13.14 is that? Oh, yeah.
Oh, yeah. Okay, so his answer was a little bit different than mine because he used this function instead of this one. So no offense, he's closer to the truth. Me, because I didn't use the rounded off answer.
Yeah. Good.
Okay. I'm gonna turn this off.
Fred,
I'll check my grade.
That's not my
Fred,
name.
she just owned your whole table.
That's not my name.
Go to the bathroom when I get back.
Honey, no.